In the electronics lab, you can find all the components you need for your project. All the different wires can be found on the back wall of the lab. The other components can be found in the room next to the wires. You will work with BNC wires, crocodile wires, jack wires, and other combinations of these. The most common components you'll be using are resistors, capacitors, potentiometers, integrated circuits such as the 555, 741 and 411 chips, diodes, and LEDs. It is important to be able to read resistors to mitigate error occurrence during circuit building. Generally, all the resistors are categorized and stored in label boxes. However, once the resistors are out of the box, you need to be able to identify them. You can see here the resistor color codes. Here we have a 470 ohm resistor. The first band represents the first digit, the second band the second digit. The second band from the other end represents the multiplier and the first is the tolerance. You can easily tell which end is the tolerance end because they are usually silver or gold, colors that are not used for digits. If we check, the table reads 4 for the first digit, 7 for the second digit, multiplied by 10, therefore 470 ohms. There are multiple different tables for the resistor color codes, such as this one here. And you can also find it on the wall in the storage room. A capacitor is a device that stores electrical energy in an electric field. Capacitors come in different shapes and sizes, and can be ceramic or electrolytic. The electrolytic capacitors are polarized. Remember, the short leg is the cathode and you need to connect it to ground, and the longer pin is the anode and should be connected to power. However, it can happen for the pins to have the same length if they have been previously cut, so you should always double check. Look for this band as it marks the cathode. You can read resistance and capacitance using the desktop multimeter or by using the RCL meter. To measure resistance on the desktop multimeter, you will need 2 crocodile wires. Here we have a 47 kilo-ohm resistor. Click this button with the ohm symbol on. Then connect the red wire to the red input on the right, and the black wire to the black input on the right. The device reads 46.3 kilo-ohms. That is because there is a difference between the nominal resistance given by the color bands and the actual value of the resistor. The manufacturing process is responsible for this difference and is explained through the tolerance. To measure capacitance, connect the capacitor the same way. Press Shift and Frequency and connect the wires. The RCL meter is even easier to use. Attach your resistor or capacitor here, then press the start button and the value will be displayed here. To be able to connect LEDs, you need to differentiate between the anode and the cathode. The shorter leg of the LED is the cathode and you should connect it to ground. The longer pin is the anode and should be connected to positive power. To double check, search for the LED's flat side marking the cathode. You can also tell the pins by looking inside the LED. There are 2 structures separated by a space. The biggest structure is the cathode and the other one is the anode. Potentiometers are variable resistors. They allow you to modify the resistance by rotating the knob. Potentiometers have 3 terminals. They have a fixed resistance between these 2 pins and a variable resistance between each of them and the 3rd pin. Do not connect potentiometers by inserting the Dyson pins on the same line. That will cause a short. Make sure to insert each pin on a different line. Connect one of the fixed pins to ground, the other one to power, and the 3rd pin will be the input for your circuit. For instance, you can connect it to one of the analog pins on the Arduino board. When working with integrated circuits, it is important to place them in the right way. The pins of each integrated circuit are numbered, and you will want to get them right. Always place the chips with the circle up.